Okay, there, just a little bit from yesterday that I need to finish up on. We talked about regular expressions and how they match text. We talked about the different wildcards, like the dot, the character ranges, how the up arrow inside the bracket negates what's in there, the wildcards. In addition to the dot, we have the question mark, the plus, and the star that you're used to. And so, and then the meta characters. So backslash lowercase d is a single digit, backslash uppercase d is the opposite. So the convention is the lowercase, if the lowercase meta character matches something, then if you turn it into an uppercase, it doesn't match it. So, and then white space, this is a nice one. And then the boundaries, so yeah, so, and then, yeah, I think we made it to replacements. So string, the string class has some nice methods such as matches if it's true and false if it doesn't. We have replace first, replace all. Those are the options. And the one thing we didn't get to is splitting, which is something that is going to come into play in the next, or at least one of the next exciting things that I'm going to have you do. So this is a very nice feature. So if I say split a string based upon a particular regular expression, and remember, a character or even a string is also a regular expression. It just matches exactly what that is. What that says is now, instead of matching that, it's kind of it says use this as the delimiter, meaning everything in between this regular expression is going to be considered a separate thing. So for example, if I have the string hi, comma, mom, and I split it on a comma, which is a regular expression consisting just of a single character, that will produce a string array in which the first element is this, and then the second element is that. So similarly, if I do something like if I split on, okay, now notice this here. So remember, and this should have been in quotes, of course. Okay, backslash small s is white space, meaning space, tabs, new lines, anything, any of the characters that are not visible. We got to escape the backslash in order to actually put the slash in there. And then the plus says one or more. So if I have this string, which consists of hi and a tab, mom and a space, and a new line, that'll separate each of these pieces, hi, and then mom, and then dad. And if there were one or more in there, then it would do that as well. So an example of that is, okay, so in the, let's see, was it, yeah. There's a CSV file called data, and it's just a bunch of random numbers. Separated by comma, but also there's a space in there, and this is something that I often encounter in files like this, where it's like spaces are somehow considered to be not such a big deal. So if we look at the okay, yes, in the CS20, the test split class, Okay, here I was a little extra lazy. Normally I like to have the option of pulling in a different file from the command line. Didn't do it here, got lazy. But these are all of these are these are like throwaway examples or test things that just to kind of verify something. Okay, so we're going to pull in this file, and then we're going to here's what we're going to do. We're going to read it one line at a time. So while we have a next line, I will get the next line, and now I'm going to split it based on the comma, and that's so I see it's a comma separated file. I'll split it based on the comma, and then I'll print it out. Just print out the array just to show what it does. And so when I run that, one of the things, and it's one of the things that you can see. Well, I don't know if you can see it, but notice that now there are actually two spaces here. One is the space that the array's toString produces between, that's just how it writes it. But there's a second space here, which is because when I only split on the comma, it treated the space as if it was part of the data. And that can be a little problematic, because now if I now want to process these as numbers, then that space may be a problem. I mean, as it turns out, I think the way that Java parses it, it's not such a big deal. But nevertheless, when you have data, you want it to be as clean as possible. And here, the data is a little dirty. So how can we fix that? Well, we can fix that, in fact, with by changing this regular expression, in fact, into this. So remember, with a bracket that says pick one of the options inside the bracket. And so now, actually here, if I make, this will allow things like, supposing there was some extra dirt in here, like tabs and stuff like that. Let's put a tab or random tab in here. So and then let's see what it does when we run it without that. And as you'll see now all of a sudden there's even more garbage in there. All right, so let's fix that by choosing space or a comma and one or more of them, because as you can see, really the delimiter is sort of space or white space or comma, and if I have one or more of those, it'll treat that whole chunk as a delimiter. And so if I run that, then you notice, see the difference? Like this space here is not part of the data. This space here is what the array's toString produced. Okay, so you see how that goes? And here I don't know if you're, I don't know if you remember this. So every now and then you have, you do something and you say, well, okay, I don't want to do that. So one way to undo it is to right-click on the file, and I choose Git, Revert Modifications, and it says remove on, and then if I only do it on a file, then it just does it for that. So now it puts the data file back to the way it was in the beginning, and this is actually something, this is actually a better way of doing it, so I will keep that. I will commit that. And then I will push it. Okay, so any questions about that, about regular expressions? And it's all crystal clear. Wonderful. Okay, so let's see. Now we can. Okay, so now today we are going to. Okay, so there are actually kind of two flavors, inner classes and nested classes. The difference is a little bit, I mean, there is a difference, but it's, I'm not going to fuss about what you call it, but anyway. Nest, get it. I'll be here all week, don't forget. So, okay, so inner classes, I should be able to create one, either a nested or an inner class, depending on what the context is, and I'll. Unfortunately, the book, for some reason, the book left this out. The book had, in most respects, the book is a lot better than other texts that. What I've one of the things I've struggled with coming up with a good textbook for this is that most of the books assume that you're just a brand new programmer, never done it before, and so they're kind of doing stuff that's just so ridiculously elementary that it's wasting a lot of time. This book seems to be at a slightly higher level, and for some reason he leaves out some important things. This is regular expressions was one of them. Inner classes and nested classes is another one. So if you remember, one of my rants is about scope, and that comes into play here. It comes especially into play into choosing between whether to have an inner class and a nested class. And the example I'm going to show you today will illustrate that. So, and this is when Java first came out. It didn't have this, and this is one of the things where certain programmers liked having this feature. It was something that was available in C++, and Java wanted C++ programmers to give up C++ and move to Java, so they responded to the demand for this. And actually, my when they first came out with this, I was actually kind of against them, because why? Because I don't like C++, and so if it was in C++, I don't like it. So, okay, that was my own bias. But I've come to see their value, and so I've kind of come around on this. So what is in it? There are actually 4 different flavors of inner classes, 2 of which are good, 2 of which are horrible, and even the one horrible one, there was exactly one use case that I found where one of the horrible ones is actually sort of okay, but we'll cover that when we talk about graphical interfaces. Okay, so what is an inner class? Well, an inner class is defining a class within another class. So it's like, think Russian nested dolls. In fact, you can nest them as deeply as you want, although that's not a good idea. I have not found any use beyond one nesting. So in other words, within a class, you can define another class inside of it. This is the one exception to the one class, one file rule. Again, the Java, one of the really good things that Java had was the one class, one file, and the name of the class is the name of the file. You've seen that. So what's the benefit of that? It's like in situations where that doesn't come into play, and if I'm looking for a particular class, and it could be anywhere in a bunch of randomly named files, then how do you find it? Here it's like, if I'm looking for a class with a given name, it's going to be in a file of that name. Much easier. But this is an exception to that. So here I have now I have another 2 classes, but one is inside the other. You can have all of the access modifiers of the class itself. In almost all cases, you want to make it private. There are a handful of use cases that at this level of programming we don't really have to encounter, where sometimes you make them public. That's almost never a good idea. In almost all cases, making them private is the best practice. So make it private. only instantiated in the outer class. So you have an inner class and an outer class. So that's just so if you make them public, that means you can kind of do stuff with them outside, and that's usually a bad idea, because these inner classes have access. Well, especially an inner class has access to everything inside of its outer class. And why? Because of the scope thing. So the inner class is, the whole class is like within the scope of the outer class. And so it has, all inner class methods have access to the outer class variables, both instance and method. Every now and then we'll see this. This will only come into play later when we talk about graphical interfaces, and particularly the Swing framework. But then it becomes a little ambiguous. Remember the keyword "this," which is a horrible keyword, but we're stuck with it. Normally in a class, this refers to that particular instance of the class. But if I have an inner class, I have two thises running around. I have the this of the outer class and the this of the inner class. So which one is it? So if I'm in the inner class, then the this refers to the instance of that inner class. Every now and then, I want to refer to the outer class. And how do I do that? Well, the way to do it is by, and we won't see an instance of this until graphical interfaces, but we do it by the name of the outer class dot this. That refers to the instance of the outer class, that particular instance of the inner class is there. So we want to avoid instantiating outside the outer class, and then there is something called an anonymous inner class that for some reason some people like, and it's really a terrible thing, so don't do that. So, and I'm not telling you how to do it, so but if you kind of go on Slackdot or something, Stack Overflow, then you'll see. And if you in certain tutorials, especially in doing Java's graphical interfaces, for some reason they like using these anonymous inner classes that I'm not telling you about, and you shouldn't use. Anyway, so now a nested class, and the terminology is, it's important to distinguish them. An inner class is like sort of an instance thing associated with it, but a nested class is an inner class that's defined with a static modifier. And the difference is this: is that in a nested class, because it's static, it does not have access to the outer class's instance methods and instance variables. But the thing about a nested class is just because it's static, there's only one instance of that class per outer class. Whereas with an inner class, you have multiple instances of it, and you want that because each instance is going to have to refer to the other one. So if you don't need access to those instance variables in the outer class, then a nested class is preferred. But if you need it, then you want an inner class, that is without the static. And we'll see an example of both of them in the thing. So, and one of the other rants that, and again, you can agree or not agree, but for the sake of, oops, how did that get in there? Okay, so here's the thing about that. As long as the inner class, if we keep that nested inner class private, then direct access to variables does not break encapsulation. In other words, normally if I have two different objects, then I do not want to allow direct access of one to the other. Why? Because I want to preserve the, preserve the data. In other words, the objects are data and methods. And the idea of this is that if only the methods in the object can change the data, then what that means is that if I'm running the program and the data does something weird, then I know where to look. So the encapsulation was one of the principal ideas that in object-oriented programming. So direct access from the outer class to the inner classes, nested instance variables, that is acceptable. So, and we'll see an example. That is normally, if I have one instance referring to stuff, I always want to use a getter, if it's just normal objects. But if they're encapsulated, then I don't need to do that. And it doesn't violate encapsulation. Again, this is as long as it's private, as long as everything is private, then it's okay. So we'll see an example of that. And we'll see an example right now. So, okay, so when we were talking about the collections framework, one of the issues, if you will, of that is that they can only contain objects. So if I have a linked list, for example, and I want to have it hold integers, say, then I can't put primitives in there. I mean, it can look like I'm putting primitives in, but because of auto-boxing, it's not actually putting a primitive in. It's wrapping it in an object and putting that object in there. Well, what if I want to have a linked list-like thing, but I want it to hold primitive ints? So Java won't do that for me, so I got to do it. And this is an example of inter classes, interfaces, kind of using them to do something similar to what we've already done. If you remember back when we were talking about collections, they had this iterator thing. And I got an iterator by asking the collection, give me an iterator. Now that iterator was an interface. If I didn't point that out, you should notice that. So, and we can't instantiate an interface. So how could I get an interface instance that's actually an iterator? Well, inside that collection, it was actually creating it and passing it out. And what we're going to do is we're going to look a little bit at a version of the sausage factory about how that works. And it's how it uses this inner class idea to do that. And now to implement a link, okay, well, I want to implement a linked list. I want it to hold primitive int values, okay? And I want to create the ability to use an iterator to loop through it and then optionally remove the selected items. Okay, so remember one of the things about in a collection, if I'm iterating through the whole thing and I want to remove something based upon a certain criterion, then the way to do that is using an iterator. That's really the only way to do it. Okay, so so just to sort of design this thing, actually here's, there's the design. An int linked list, and here, so let's kind of go from, the idea is that inside, here's how a linked list, and this is a doubly linked list. For some reason, again, back in the early days when computers were these tiny little things that filled a whole room, conceptually, they wanted to squeeze out every last little bit of storage. So they had, these singly linked lists where you could only go one way. And they said, well, the doubly linked list kind of goes back and forth. They say, but that takes up too much room. well, in practice, anyway, we're going to do a double. So this is kind of how it worked. Like each of these nodes has 3 pieces of data. You have the value itself that it's holding, and again, here we're going to put ints in, but you can put anything, if you define them. So we're going to define it using ints, and then you have a reference to the previous one and a reference to the next one. And in addition to that, you have a reference to the first one, which will, and then a reference to the last one. So in the first one, the previous one of the first one is nothing, so it'd be null. And then if it's the last one, then the next one after the last one is going to be null. So when you start off, everything is null. So here's how it works, and we're going to implement that using this node idea as a nested class. So we're going to have the node as a nested class, and it's a nested class. We can use it as a nested class because it actually does not refer to, it doesn't have to use anything in the outer class. So that's when you're writing an inner class and you do not need access to the instance variables of the outer class, then write it as a nested class, in other words, static. Now the other piece of this is that now is the iterator piece. Now Java has an iterator interface, but the problem with that is that it's a generic, which means I can only use it for objects, and so I have to write my own interface. I call it an int iterator, and it has just basically the same type of methods. So I have next that's going to return an int that points to the next one, a Boolean that says whether I have next one, and then remove. Okay, this says int. I think I might have changed it to void, but anyway. Okay, and then I'm going to have an inner class. I'll call it int linked list iterator, and it's going to it's going to have an int that's going to be sort of the next thing, and it's going to implement each of these 3 methods. And so that's going to be an inner class, whereas node's going to be a nested class. And then here for my linked list, actually for instance variables, all I need is a reference to the first and the last one. That's really all I need, because the nodes themselves will have keep track of everything in between. So I have an empty constructor because I need to instantiate those. I want to add and then kind of add all. I can add all an array, add all another int linked list. I could have had another add all from a Java collection if I wanted. Maybe I'll leave that as okay. So here I want a get. So now the get get is going to be the index. So this says get the index, and it's going to return the value of the index in there. And now, if this were an array, if I were doing this like an array, that would be easy. As a linked list, that's going to be a little harder. So I need to do a little bit of work there. Now, if I'm not iterating, I should be able to kind of remove. So I need 2 of them. One is remove a particular value. With Java's lists that you can hold integers, there's like a little bit of ambiguity there. So so here this is removing the element at this index, but then I'm sorry, this removes the first instance of the value, but remove at removes removes the element at that index. And then things like clear convert it to an array, get first, get last, get size, and then iterator, which is going to return the iterator thing. So let's look at what that looks like. Okay, so we don't need you guys anymore. And okay, so there's a package called inner classes. So all right, so let's look at the interface first. So here's the int iterator interface, and this is all directly from the this. Okay, I did change that. So remove is just a void, not an int. I think I was thinking, well, let's remove it and return it, but usually you just want. Okay, so remember, with an interface is a contract to. This says that anything that implements the iterator, if it's not abstract, will implement these three methods. But let's look at the. Here's our int linked list to begin with, but let's start with the and then notice how one of the nice things about NetBeans is that it when I have inner classes, it will kind of list them here as well. So here's the inner class node, and I've defined it to be static, which means it's not actually an inner. The terminology gets a little, an inner class that's static is a nested class, and not going to fuss about that. But okay, just right from this, I have 3 instance variables: value, previous, and next. So and they are, I have the nodes that point to the previous, the next, and then here's the actual value. The constructor just sort of sets them. And then it turned out that for the toString, just for debugging purposes, I just kind of did the value. And then notice there aren't any getters, because the only thing that's going to be accessing this is the outer class. And since it's declared to be private, see, the private static class node, since it's private, then there's no encapsulation harm in having the outer class directly access these. Okay. So now how do we get started? Now let's look at the outer class. So I have 2. Oh, sorry, that's that one. Here, yeah. So I have, oops, I think I forgot, did I forget? Yeah, I did. I forgot to put this in. Okay, I have a node that's first, a node that's last, and then an int that's the size. So that's going to tell me how many items that are in there, and that becomes important. So when I initialize it now, and when you have objects that are null, you want to be careful to avoid null pointer exceptions. That can be a little bit too easy to create. But when the thing is empty, there's nothing in there. So that means the size is 0. The first one points to null, and the last one points to null. Okay, and these are the instance variables of the int iterator, the int linked list. Okay, so how can I add something? That's really the most important thing. So I add a value. And so the first thing I'm going to do is I'm going to add it to the end. So in a linked list, when you add, you always add it to the end. And so I always, the previous, I'm going to stick it on the end. And that means that the previous node of the last one is now going to be the previous the current last. And it's the next one is going to be null. Okay, so this new node is going to be the last one now. Now there are 2 possibilities. If the last node is not null, then all I need to do is set the next one for the last node equal to the new node. So the last one on the previous, before I did this, the last node was pointing to null. Now, if there actually is a node there, then it will point to the new node. So now the next node for the previous last one is now the new one. And so now the previous last is the next to the last, and the new one is the last. See that? That's all you need. But what if what if the last is null? Now the only way the last is null means that it's the very first one we're adding. So if it's the first one we're adding, now notice that what that means is if I get to here, that means last was null. So now the new node, the previous one is null, the next one is null, and so I need to set the last one to my new node. That's really what I need to do. Because if I only have one in there, the previous one is null, the next one is null, but now the last one in and the first one is in. Okay, so here I'm setting if it's empty. In other words, the first one is a new node, and the last one is so the first and the last. And now I'm just one more than the previous. See that? Now all the add-alls are just, I just kind of buzz through things. Now, okay, get first. So, okay, so how can I get first? Well, if I'm getting first on an empty one, then I'm going to throw an exception. Because if I say, okay, here, why am I getting a first one? Because I think there's something there. And so it's my responsibility to make sure that there's actually something there if I'm going to get the first. So I'm going to be mean on this. And so if there is a first, I'm going to return that. And I'm going to return the value of that. Because I don't, on the outside, I don't care about the node. These nodes are, I don't care about them. What I care about is the value. So I'm going to return the value if it's not null and throw an exception if you're trying to get something that's not there. Okay, the trickiest one is if I want to remove something. So I want to remove a value. So how do I, now I have to do a bunch of work. I got to go and I got to find that value if it exists. And what I'm going to do is I'm going to return a Boolean that says whether I found it or not. In other words, if I go to remove something that isn't there, then, okay, what are the choices? Well, I could throw an exception, but that's extra mean. And you don't want to do that. Because if I say remove something that's not there, I want it to just be silent about it. But I want to also let you know, oh, by the way, I did, this wasn't in there. Okay, so that's a choice. It's not a law of nature. So I'm going to have a Boolean that says, okay, this is whether I found it. And I'll say it's false because I'm going to say, well, okay, I'm going to assume it's not there. Now, if the first is not null, then I'm going to do some work. But what if I'm trying to remove a value from something that's not there? Now, unlike the other, I'm not going to throw an exception. I'm just going to say false, wasn't there. Maybe I should have thrown an exception, but it was a choice not to. Now, if it's, but if there is stuff in there, then I need to go looking for it. So how do I do that? Well, I basically step through the nodes. So I start with the first one, and I know the first one's going to be there because it's not null. And so here's my, now I have a choice. I can either do this in a while loop or I can do it in a for loop. And the competing criteria are the scope of, for the narrowest scope, use a for loop. The problem with that is that it's kind of messy and I don't like the way it looks. So for this, for while loops, you have to define the criterion variable outside of the while loop. a little bit wider scope, but so, okay, so start with the first one. And while it's not null, and actually a do while might have worked here too, because if I make it to here, then I know that there's at least one. But nevertheless, while it's not null, so if, now I can test double equal, why? Because these are integers. If this were doubles, I would need to use some sort of criterion for, if it's within some epsilon of it. But okay, so if I found it, then, okay, now remember I'm removing it. So if I found it, then I'm going to say found is true and break. Remember, break breaks you out of whatever loop you're in. And then once I break out, if I break out, actually this. This is an error. This should be here. Okay, so if I found it, I'm gonna what I'm doing here is I'm calling a private method called unlink. So let's look at what unlink does. That's important. Okay, so notice I have a private instance method, and why? Because this is kind of messy. And if I try to, and this is something that I actually want to do on at least a couple of occasions. So I kind of, this isn't something that I want anybody else to do. This is just sort of a helper method to make my code a little cleaner. So this says I want to unlink. I want to take this node out of the sequence. So first of all, if I'm trying to unlink a null one, which ideally should never happen, and I just say, okay, forget this. But now I know that node is going to be not null. And so I'm going to look at what's the previous one, what's the next one. So what is it I have to do here? Well, what I have to do is basically, so like say if I'm unlinking this guy, what that means is that I need to take this next and point it to him, and then take his previous and point it to him. And once I do that, then this thing is gone. So that's basically what I'm doing here. But there are some little, so what are you have to watch out for edge conditions. The edge condition is that what if it's the first one? What if it's the last one? So, anyway, so it does all that. And then, so notice that I'm directly accessing the instance variables of node. So, I'm allowed to do that. Okay, so the rest is fairly straightforward. So let's look at the other inner class, which is the iterator. Okay, so I have this int iterator interface, and again I declare this to be private. That means nobody else can get their hands on it. So everything is all self-contained here. And so so for my iterator, I want two instance variables. I want next node and the previous node. So when I instantiate it, I want the next node to be pointing to the first one and the previous one to be null, or actually the previous one, the first previous one is going to be null, so that, Now, so what does next do? Well, if the next node is not null, then I set the previous, now here, the previous node to the next node, and then the next node to the next of the next node. And I return the value of the previous node. The reason I'm saving the previous one is because when I go next, I've sort of advanced past the thing. I'm now pointing to the next one, but what the user wants is the value of the previous one. So that's what I'm returning here. Has next is simply if the next node is not null. And just sort of a stylistic thing here. For some reason, the tendency of in something like this, there's a tendency to say something like, if the next node is not null, return true, else return false. And it's not that that's wrong, it's just really bad style. I mean, it's writing, it would be like writing your master's thesis using grammar at the level of kindergarten. So the reason we have Boolean expressions is that the has next is going to be true if next node is not null, and it's going to be false if it's null. So just put it in one expression. And this reads much more clearly, in my humble opinion. So now if you like doing it the other way, then it's not that it's wrong, but I'll complain about it. So I won't take any points off, but I'll complain. So okay, and then remove. Okay, so now here's where we can use the instance method of the thing. If I want to remove, then what I've done is I want to remove the node that I just passed over. And so if it's not null, then I can simply unlink it. And because I'm an inner class, I have access to the instance method of the outer class. Now, the nested class node can't do that. Why? Because node is declared to be static, and so as a static thing, it can only see other static things. So the node class would not be able to do this. But the iterator class can do it because it is not declared to be static. Okay, all right, I want to give one. Here's this one. Okay, so basically I want to see, like, I want to, let's just sort of, I want to time this, so. All right, I want to generate a bunch of them. And I want to see how long this takes. So here's how to time things. There's actually cleverer ways of doing this, but oops. What the heck? So these are milliseconds, so 1,000 of them are seconds. Okay, so okay, 0.0. All right, so let's do a few more. All right, so now I want to, just for, how does this do compared to let's oops. Okay, I basically want to do the same thing for this guy. And then I want to do the same thing for this. Okay, so so here I'm using primitive ints, and I think, okay, what is the Java collection do that this doesn't? Well, in Java collection, every time I add something, I've got to wrap it, and even if I have to get it, I have to unwrap it, and there's a lot of, in other words, does that affect the performance any? Well, let's see. Okay, so so the int one took like 0.75, and the other one took over a second. So I mean, does that, like, what if I want to a little bit over, but if I'm generating a bazillion of these, okay, so this was a little over 8 seconds to generate 100 million, or to add 100 million. It would not generate, I should have said add, but, and Java's took like almost twice as much time. So, okay, so it's like sometimes you can kind of beat the generic one. It's not totally recommended, but in some cases, you know, things like this can kind of do it. But the main thing is these inner classes. You know, so inner classes, nested classes, they're very valuable. We're going to see a lot of this when we start looking at graphical interfaces in order to make things actually do stuff. So it's these inner classes that are going to be doing the stuff. And I think it's a nice way to kind of do it. So, all right, a little bit over. See you tomorrow. For the next, we are going to now look at multi-threading.